Hello, this is Mrs. DB, and today we're going to go over Chapter 3, Section 3 on proving that lines are parallel, given what we have learned earlier in this chapter about different angles and which ones are congruent and which ones might be supplementary. For a warm-up, I just want to kind of review these problems because you will need to know what converse is. So try these problems. Number 1, if A equals B, then A plus C equals B plus C. Write the converse of that. And that would be if A plus C equals B plus C, then A equals B. Okay, number 2, if measure of angle A plus measure of angle B equals 90, then angle A and angle B are complementary. The converse of that would be if angle A and angle B are complementary, then the measure of angle A plus the measure of angle B is 90 degrees. That's the definition of complementary. And then number 3, if AB plus BC equals AC, then A, B, and C are all collinear. Remember, AB is the length of segment AB, BC is the length of segment BC, and so on. That's the segment addition postulate. Okay. Our objective today is to use the angles formed by a transversal to prove that two lines are parallel. So when you have two lines and they are cut by a transversal, we want to look at the measures of the angle, say angle 1 and angle 2, and if they are congruent to each other, then we'll be able to say that these lines are parallel. So in section 2, we first started with that you had two parallel lines, and then they're cut by a transversal, and then we knew the lines were parallel, and then we learned things about the angles. Like we learned that corresponding angles would be congruent, and we learned that alternate interior angles would be congruent, and we learned that alternate exterior angles would be congruent, and we learned that same side interior angles would be supplementary. Now in this lesson, we do not know that the lines are parallel until we see things like corresponding angles being congruent. If the corresponding angles are congruent, then we can say the lines are parallel. So it's a little bit different way of going at it. It's the converses of the postulates and the theorems that we learned in the last section. Okay, the converse of a theorem is not automatically true. It has to be proven true. So it has to be proven with, a separate proof. All right, so here's remember that the postulate from the last section was if you have parallel lines, then corresponding angles are congruent. Corresponding angles are congruent. That was our postulate from the last section. Now this postulate is if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So it's just the converse of the other one. So if angle 1 is congruent to angle 2, then line M is congruent or is parallel to line N. Okay? Here's an example of how you might use this problem. It says that we've got this picture shown here, and it says that angle 4, here's angle 4, is congruent to angle 8. Well, those are corresponding angles. So since they are in the corresponding angle position, that means then that those two lines, L and M, are parallel because of the converse of the corresponding angles postulate. It's important that you put the converse in front because it's not the corresponding angles postulate, it's the converse of it. Here's another example. This one says that we have measure of angle 3, here's measure of angle 3, is 4x minus 80, and the measure of angle 7 is 3x minus 50, and it also says that x is equal to 30. Okay, so that means that you can substitute in 30 for x in both of those expressions. When we do it in the angle 3 one, we get 40. When we substitute 30 in for the measure of angle 7 expression, we also get 40. We got 40 for both of them, which shows that angle 3 is congruent to angle 7, or that their measures are equal by the transitive property. So therefore, we know, using the definition of congruent angles, that their angles are congruent, which means then that by the converse of the corresponding angles postulate, that those two lines are parallel. Now, on your assignment, I don't expect you to, this is basically a whole formal proof here. I don't expect you to do all of this on your assignment. I do expect you to see if you get the same thing. If you substitute in and get the same answer for both of them, then you'll know that this is true, or either one. You can just write one of them as true. And then that means that the converse of the corresponding angles postulate is true. So you don't have to write all your steps and reasons, but you do have to substitute in and see if you get the same result, and if you do, then this is true. Okay, so this one's easy. This is just saying if measure of angle 1 is equal to the measure of angle 3, then that means that those two angles are congruent, which means that then you have parallel lines because of the converse of corresponding angles postulate. So you would need to write this. Okay, now this one, here's what we'd have to write. You need to do the substitution part. You don't have to write the reasons, but you need to show that if you substitute 13 in, what you will get for each of them. So you'd get 77 for measure of angle 7, you would get 77 for measure of angle 5. So because you get the same thing, then you can go to the last step, which says that by the definition of corresponding angles postulate, the lines will be parallel. This is a nice little teeny tiny postulate saying that through point P, here, not on line L, there's exactly one line parallel to L. Well, let's see. Parallel to L means that they'll never intersect and they'll always be the same distance apart. There's only one line through that point that would be parallel to L and also going through that point. The converse of the corresponding angles postulate is used to construct parallel lines. The parallel postulate guarantees that for any line L, you can always construct a parallel line through a point that is not on L. All right, so we have these theorems here now. Number 333 says the converse of the alternate interior angles theorem. So the first theorem that we learned in the last section, the alternate interior angles theorem, said that if you have parallel lines, then alternate interior angles will be congruent. This theorem says that if you have two coplanar lines cut by a transversal, so that a pair of alternate interior angles are congruent, then the two lines are parallel. Converse of the alternate exterior angles theorem starts out the same way. If you have two lines cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. And the same side interior, remember this one isn't that they're congruent, it's that the sum of them is 180. So if you have supplementary angles, when you add together the measures of angle 5 and 6, then the two lines are parallel. So let's check and see if we can figure out whether these lines are parallel or not. It says that angle 4 is congruent to angle 8. So in section 1, we learned that if this is our transversal here, these two lines, we don't know if they're parallel or not, but angle 4 and 8 are still called alternate exterior angles, whether or not we have parallel lines. Now it says right here that angle 4 is congruent to angle 8. If that's true, then the converse of alternate exterior angles theorem tells us that those lines must be parallel. So you identify what those angles are, and if they are congruent, then you look and see if you can use one of these theorems or the converse of the corresponding angles postulate in order to say then that you have parallel lines. Okay, in this example, the work is already done, but it says use the given information in the theorems you have learned to show that this is the same one. Nope, this is a new one. Okay, so they tell us that x is 5, so you will substitute in. Because you get 58 and 122, these are not congruent, so let's look and see. Angle 2 is here, angle 3 is here. They're not supposed to be congruent. They're supposed to be supplementary. So if we can add 58 plus 122 together and get 180, then they are supplementary, which then the converse of the same side interior angles theorem, that's a mouthful, says that these lines must be parallel. Okay, so in this one, we're looking at angle 4 and 8. Would those two lines be parallel, R and S? They would by the converse of the alternate exterior angles theorem. I think that's the same one we did. Okay, in this one, they give you what the value of x is. Let's find 3. Here's 3, and here's 7. Well, what are those two angles? Those are alternate interior angles. So if we plug in 50 to both of them and get the same thing, then we will know that the lines are parallel by the converse of the alternate interior angles theorem. And we got 100 when we plugged it in. So we would say that these lines are parallel by the converse of the alternate interior angles theorem. Okay, now we're going to do a proof. We are given that P is parallel to R. See, they're marked with the little red arrows. Those two lines are parallel. We don't know if the other two are. We are also given that angle 1 is congruent to angle 3. We're going to see if we have enough information to prove that line L is parallel to line M. All right, so for the first thing that we're going to do is put down our given. We're going to write down that P is parallel to R, and that is our given information. Next, I'm not going to put the other given down yet. I'm going to say that, look, angle 3 is congruent to angle 2 because here's my parallel lines. I'm ignoring line L right now, and it's cut by a transversal. These are alternate exterior angles. So because those lines are parallel, I know they're congruent. Now I'm going to put down my given. Angle 1 is congruent to angle 3. I could have put the given before this, it wouldn't matter. And I say, angle 3 is congruent to angle 2, and also angle 3 is congruent to angle 1. So I bet you know what's next, the transitive property. The transitive property of congruence says that I can put these together, jump over the angle 3, and I have angle 1 is congruent to angle 2. Angle 1 congruent to angle 2. Well, if angle 1 is congruent to angle 2, then by the converse of the corresponding angles postulate, line L must be parallel to line M. So there's a little proof that proves that L is parallel to M. Okay, here's an application problem, a carpentry thing. A carpenter is creating a woodwork pattern and wants two long pieces to be parallel. Measure of angle 1 is going to be 8x plus 20, and measure of angle 2 is 2x plus 10. He also says that x is going to be 15. Show that these pieces are parallel. So because they are same side interior, that means that angle 1 and 2 are supplementary. So if we can figure out that, where this is going to be our transversal here, and these are going to be our lines, and we're going to try to figure out if I put x equals 15 in there, if I get supplementary angles. All right, so there's measure of angle 1, and I'm going to substitute the 15 in, and I get 140. Now, remember, you're not going to get the same thing for both of these because that would be congruent, and that's not a postulate or a theorem for angles formed by lines cut by a transversal. But we do get 40 for the other one, and if I add 140 plus 40, I get 180, so that means they are indeed supplementary. So then I can say that by the converse of the same side interior angles theorem, let's see, what were my lines? Oh, it's just piece A. Piece A is parallel to piece B. Okay, so And remember that you are going to be showing that lines are parallel, if you can, by one of the converses of the theorems that you learned about in section 2. Let me know if you have any questions. Thank you very much.